So in the previous lecture, what we have done, first we have written a differential equation, a partial differential equation rather, of second order, and the differential equation were written as this, where u is the independent variable depending on two independent variables x and y. So firstly we have written this partial differential equation, and then we have transformed it. We have transformed the space from xy space to xylem eta space, where xylem and eta both are the functions of x and y. And what we have obtained, we have seen that we can write the whole thing as a bar u xi xi, b bar u xi eta, c bar u eta eta, d u xi e u eta f u g bar. So we have transformed that, okay, and we have written already that what is a bar, b bar, etc. Right now, the point is what we are trying to do, that we will apply the whole thing for some different equations. So first we take for hyperbolic equation. And for hyperbolic equation, what we know, that this b square minus 4ac, that thing should be greater than 0, and for that we say a bar and c bar, these two do vanish, and so these two equations will give us the coordinates eta and xi. How? So as we have written earlier, we will just check that your a bar is equal to this and c bar is equal to this, so these two things will be equal to 0, right? So we write that a xi x square plus b xi x xi y plus c xi y squared is equal to 0, and a eta x square from the c bar's equation, from the c bar's equation we see that eta x square plus b eta x eta y plus c eta y square is equal to 0 as well, right? So what we get from that, out of that, so we can write actually this equation as a xi x over xi y square, b xi x xi y plus c is equal to 0. Similarly, you can write this as eta x eta y b eta x over eta y plus c is equal to 0, right? And now we can solve these two equations, and we can write it as xylem x by xylem y is equal to minus b square minus 4ac over 2a, and similarly this over this is equal to minus b square minus 4ac over 2a. And to follow that, as we have taken a hyperbolic equation, this part is positive, this part is positive, so we have two distinct real equations, real solutions, right? And actually b square greater than 4ac, this is implying that the slopes of the curves, say eta xy, this should be constant, and this should be real rather, and So I mean, if b square is greater than 4ac, then at any point xy there exist two real directions, and given by two roots of the equation, and along which the PDE we are constructing the PDE, and the PDE, I mean, actually we are transforming the PDE in its related canonical forms in these directions, and these two equations are called the characteristic equations. And for two solutions for such quadratic, we consider that only one solution of each, and we can process the equation. And how? Follow that if you consider that exy is equal to c1, then obviously d xi should be equal to 0, right? And on the other side, d xi is equal to xi x dx, xi y dy, right? And as this part is equal to 0, so you can write as dy dx is equal to minus of xi x over xi y. So this is actually some slope. Similarly, the next equation, I mean, where you are taking that eta of xy is equal to c2, this immediately can bring you to this equation, or the slope of eta x over eta y. Now if we integrate these two equations, then we obtain the equations of family of characteristics. Number 1 is given as this, and number 2 is given as this. These are the characteristics of the given PDE. And now to obtain the canonical form of the same PDE, we will substitute xylon and eta in that equation, and we can obtain the canonical form of it. So how we will do that? I will give you an example. So we are taking one equation as, say, 3uxx plus 10uxy plus 3uyy is equal to 0. So we see at the first that a is equal to 3, b is equal to 10, and c is equal to 3. So b square minus 4ac is equal to 100 minus 36 is equal to 64, which is greater than 0. Hence the given equation is of hyperbolic type, and the corresponding characteristic equations will be given as dy dx is equal to xylon x by xylon y, and we take it the positive value, so this will be minus b plus 64 over 6, and this is 8, and this is minus 2, the numerator is equal to minus 2, so there should be a minus sign, right? As we have obtained just before. See, this should be minus, and so this is equal to 1 over 3 then, and the other that is the dy dx equal to minus xi x over xi y, and that thing is equal to minus 10 minus 64 over 6, and this is 18, so this is equal to 3. So we integrate these two equations, that is dy dx is equal to 1 over 3 and dy dx is equal to 3, and we obtain that the first equation is y is equal to 1 by 3x plus c1, and the other is y is equal to 3x plus c2. And as we have promised that the c1 is equal to xi x, so we are writing as xi is equal to y minus 1 over 3x, and eta is equal to y minus 3x. Now we will convert the whole story. So you can actually use the formula directly, or you can even differentiate them. So one by one. Okay, so first a bar is equal to c this is equal to 3 minus 3 square plus b is equal to 10 multiplied with minus 3 into 1 plus 3, that is the value of c, is equal to, this is equal to 0. See, now as we have said that we will take that a bar and c bar c as well, so we got that. Similarly, if we check that c bar should be equal to 0. Now the question is, what is the value of b bar? B bar is 2 into 3 into minus 3 1 over 3, sorry, minus 1 over 3 plus 10 minus 3 into 1 plus 1 into 1 over minus 3 plus 2 into 3 into 1 into 1, and this is equal to 6 minus 100 over 3 plus 6, that is 12 minus 100 over 3, and this is, that is 36 minus 100, so this is minus 64 over 3. D bar, as it constitutes of e xx eyy kind of terms, and we have seen that our xylem is already of in first order of x and y, so this is equal to 0, and e bar is equal to 0 as well, and f bar is equal to 0 as well. So the required canonical equation turns to be minus 64 over 3 u xi eta equal to 0, that is u xi eta simply is equal to 0. And if you now solve, try to solve this, so this is simply, whenever you are solving, first take eta as a constant, then this, we are trying to integrate it with respect to eta, that is xi is constant, and this is equal to some f1 of xi, say, and then integrate the whole thing with respect to xi. So this will be u xi eta is equal to integration of this, obviously that is another function of xi, and arbitrary function of eta, if g, we should write g, will come out as the function, arbitrary function for partial differential, partial integration rather, we can say. So this is, if you write in terms of x and y, then this turns to be f of y minus 3x plus g y minus x over 3. Simply we have solved this differential equation. In the next day we will start with the canonical form for parabolic equation and canonical form for elliptic equations.